All right, today we're looking at 11.7. 11.7 is mixed expressions and complex fractions. Today we're going to simplify mixed expressions, and we're going to simplify complex fractions. Ugh. Okay, so the first one that we're looking at, example number one. Example number one, we have 2 plus 4 over x minus 1. Well, this one here, we can't add them because we do not have common denominator. So it's just like if I go 1/2 plus 1/4. Can't combine them. I got to get common denominator, so I need to multiply this one by well chosen 1. So 2 over 2. So 2 over 4 plus 1 over 4. Now I have common denominator. Add the numerators. So 3 over 4. So just basic fractions. That's what we're going to do. That's what we're looking at. And so we look at this. We need to get common denominator. This is over 1, which we know everything's over 1, so that's okay. But we need an x minus 1 over here. So we're going to multiply by x minus 1 by 2 plus 4 over x minus 1. And we also divided by the x minus 1, that group there. So that way we have the same denominator here. I distribute through, so I have 2x minus 2. So 2 needs to be multiplied there, 2 needs to be multiplied there. Everything inside needs to be multiplied by the 2 using distributive property, plus 4 over the x minus 1. So it's that common denominator. I combine the numerator, leave the denominator alone. It combines over. So then I do the math here. So I have 2x plus 2 over x minus 1. Check the books, see if they factor that out one more time. Nope, they leave it right there. It would be okay if you want one more step. Like that. And simplify to that. So that would be okay as well. So either one of those would be okay on some kind of standardized test. Do not be surprised if either one of those is the final answer. Okay. Look at example number 2. Red marker does not like to erase. Okay, example number 2. Real world example. Refer to the application at the beginning of the lesson. Find the average speed of the top fuel dragster in a mile per minute. Okay. Top fuel dragster is a 1/4 mile per 4.24 and 2/5 seconds. Okay. So, mile per minute really doesn't make a whole lot of sense to us. If you say miles per hour, people understand that. And so mile per second, they went a 1/4 mile in that time. So what we're doing is we're going to try and simplify this. Whoops. Using those railroad tracks. So I go right here. I'm in miles, so that's good. I need to change seconds to miles per hour. So 60 seconds is 1 minute. 60 minutes is 1 hour. Another thing we could have done, so we have that. If we want to think ahead, if you understand this, that's great. Go to a little advanced concept. I could say 3,600 seconds or 1 hour. And we know that our units cancel, so we're left with miles per hour. So this is another way that we could do it. So when we're doing this, we have fractions and fractions. Ugh, not very nice. With this, I'm going to change this into just a fraction instead of a mixed number. So it's going to be 22 over 5. I'm going to wipe that out. So I have 22 over 5 here. So we have that right there. So when we simplify this, I then say, well, what I need to do, I need to take 3,600 divided by 4. I know that I'm just looking at this as 36. So it looks like it's 9. So 900 is going to be the top. And then I have 22 over 5. So just doing some quick math like that, I cannot do 45, 4,500 divided by 22. In my head, very easy. So I look at the book. I cheat. Look at the book and say I have 3 and 9 20-seconds. So the average fuel for the top fuel dragster is 3 and 9 20-seconds. Miles per, oh, they just want miles per minute. This is miles per hour. Oh, because I did not do the math right. So 4,500 divided by 22. Which is 204.5. So miles per hour. It helps if I read it a little bit closer. They wanted it in miles per minute. So we would have just left it as, sorry, going back, 60 seconds, 1 minute. So then it simplifies out a little bit better. That's your final answer there should have been 3 and 9 over 22. See, the miles per minute is not a nice unit. So that's why I went to miles per hour. Miles per hour, 204. That's pretty fast. Okay, 3 and 9 20-seconds. I think they're going 3 and 9 20-seconds, miles in 1 minute. So they're covering over 3 miles in 1 minute. So you know that it's pretty fast. All right, next example that we go to is example number 3. We have complex fractions involving monomials. Okay, so we have monomial. Really, it's not a monomial because 1 over b is not a monomial. You can't divide by the variable, but individually they are. So what we have to do here is we have to flip it. So I put a long division sign so I know I have this fraction divided by this fraction. To get rid of fractions, we know that we reciprocate and multiply. So I have 8t squared over b times b squared over 4t. All I did is I'm reciprocating this, so flipping it and multiplying. So change it into something like this, and we go, oh, man, this doesn't look as scary as this. That's why it's always nice to be able to reciprocate and multiply. And then we can look at cancellation, squared b, squared t, 4 becomes a 2. So we can simplify that way. Then I just look and say, what do I have left? 2tv. Okay, so I have 2 TVs. Okay, divided by 1. So yes, this is a monomial. So when we simplify it, it does cancel everything out. So I have v, or 2 times v, 2tv. Okay, so that's the final answer. So like I said, looks really scary. Reciprocate, multiply, and boom, it simplifies out. So I can cancel stuff because it's in numerator and denominator. There's no addition sign in there, so there's nothing in there that's grouped. So I can split everything apart since everything's either being multiplied and divided. That's when it works. If there's an addition in there, then I'd have a group and it changes the whole concept on that. All right, look at the next example. Look at example number 4 here, 4a. We have this, and once again, it looks scary, but let's simplify it so it doesn't look so scary. So this implies that we have 2 over y plus 3 times reciprocate, so y squared minus 9 over 5. Looking at this, going, man, I don't see anything jumping out of cancellation. Oh, wait, can I factor this? I got a y squared. I can maybe factor that. So 2 sets of parentheses. This tells me the signs are opposite. It tells me the middle term disappears, which is great because I just do the square root then. So y minus 3, y plus 3. Okay, so that's going to be up here. Looking at that and going, oh, hey, got a y plus 3, y plus 3. The entire group is there, so I can take out the entire group. So I got the 5 down here yet, so I'm going to have this as 2 times y minus 3 over 5. They could also distribute. So 2y minus 6 over 5. So either one of these 2 solutions would be acceptable. So I just kind of look at it that way. So very good. Now we're going to move on to part B. All right, look at example 4b. We have this divided by that, divided by this, whole bunch of stuff. I'm going to reciprocate and multiply this denominator, but I'm also going to factor out the numerator in the process. So I'm kind of trying to do two steps at the same time. This one tells me the signs are the opposite. It tells me the bigger one's going to be positive. 18 and difference is 7. Looks like 9 and 2. So n plus 9, n minus 2. And I distribute it back out. Yep, I get that. Divided by, I'm going to have the same kind of thing here. Two numbers multiplied together to give you 1. Signs are the same, sorry. They're both negative. Two numbers multiplied together to give you 1, and they add together to give you 2. Well, n minus 1 and n minus 1. And I write it like that instead of writing it n squared, just because of the cancellations, the powers. It's just a little habit that I got into over time. This is reciprocated, so n minus 1 over, and then this will factor into n minus 3 and plus 3. So now we have all of our groups, and I can put this in parentheses too if we want to, just so that way we feel comfortable that everything's in groups. I'm looking at cancellations, bang, bang. Thought I'd be able to cancel something like that. Does not look like, oh no, that's 9, jeez. Haha. Got stuck on that 3. It should have been a 9, huh? Because 3 times 3 is not 81. 9 times 9 is 81. So now, sometimes it's nice to know that it's going to cancel out. So I just say, what do I have left? N minus 2 in the numerator, divided by n minus 1. And since I have another group here, I'll put that stuff in parentheses. And I could put the numerator in parentheses too. Don't have to, but if we need to, just for the ease of our mind, saying I got a group divided by a group and I don't try to cancel stuff out, that's fine. But it's really not needed. So we have that. There we go. We do need them in the denominators because it's this group times that group. We have to FOIL it out. That is everything for this lesson. If you have any questions, contact me. Let me know.